Sharma and I am from CloudOps team as Ariswar and I am a DevOps engineer. So today we'll be discussing about the centralized observability. So before taking you to the solution, that how we can implement a centralized observable environment, let me take you to the problem statement, how we observed this problem and we created this solution. So with our prior experience, whenever we set up an observability for any of our project, so the major problem that we faced is whenever our servers or our Kubernetes cluster in which our application workloads are running went down, then we'll not be getting the logs, traces and metrics of those applications. So we decided to make it in a way like even after our cluster or server went down, still we'll be able to like trace and get the logs and metrics of our application. So observability has its three pillars, which are logs, traces and metrics. So logs are basically the textual records of an application or servers or any other infrastructure, and metrics are the quantitative measurement of the server and application, like how they are behaving in a certain manner and why they are behaving in a certain manner. And traces are basically the records of the communication between the microservices, or you can say the transaction of communication between the microservice architects. So let me list you the toolkits that I've used for this solution. So as we all know, observability has three pillars: logs, traces and metrics. So logs are textual records of events generated by our software or our infrastructure. And metrics are the quantitative measurement to answer like why our application or our infrastructure are behaving in a certain manner. Whereas traces gives you the answer of the communication between your microservice architecture. So the tools that I've used to implement this solution: for metrics I've used Prometheus and Grafana, for tracing I've used Jaeger, and for logs part I've used Promptail Lookie. So let me give you an example to set up a centralized observability. If you have a workload running on 3 different Kubernetes clusters. So if you want to set up centralized observability, firstly you have to select a cluster in between these 3 clusters, or you can set up a different cluster, which is a best practice of implementing this centralized solution. So you have to deploy the tools Prometheus, Grafana, Promptail and Jaeger in the cluster that you've selected for the monitoring part. And the rest your workload clusters you have to deploy the agents. Like in terms of Prometheus, we have exporters as agents. In terms of Promptail, we have Loki as agent. And in terms of Jaeger, we have to instrument the applications that are running on these 3 clusters where our workload is running. While integrating these tools, make sure that you are labeling your metrics, logs and traces so that you know which data is coming from which data source. Labeling the metrics, logs and traces will help us in the visualization part. When we visualize the data, we'll know that this data is coming from this Kubernetes cluster and this data is coming for this Kubernetes cluster. So if we want to found something, it will be easy for us. So as we are done with the solution part, let me take you to the implementation part of centralized observability. So here we have 3 clusters, cluster 1, cluster 2 and a monitoring cluster. In these 2 clusters, our application workload will be running, and in this cluster it is specific to the monitoring part, in which this cluster is specific to the monitoring part. Here we have to deploy our toolkit like Prometheus, Jaeger and Grafana Lookie. So in these two clusters where our workload is running, so in these 2 clusters we have to deploy our agents, which are exporters in terms of Prometheus, Promptail in terms of Grafana Lookie, and applications itself implemented with the Jaeger queries, and applications itself instrumented with the Jaeger queries. So while deploying our exporters or agents, you can say, we have to make sure that we are giving the endpoints of these instances. Like while we are deploying the exporters, we are giving the endpoint of this Prometheus instance. While deploying the Promptail, we are giving the endpoint of this Grafana Lookie instance. And while instrumenting the application, we are giving the endpoint for this Jaeger instance. So let's discuss about the use case of this solution. So suppose you have a workload which is running on 2 or 3 Kubernetes clusters and you want to set up an observability solution for your infrastructure. Then this solution will definitely gonna help you. You can set up a totally different cluster in which your workload is running, and you can set up a centralized observability solution which is easily to manage, and you will have a centralized data for your all infrastructure. And even if one of the cluster will went down because of some issue, then still your then still your system will be observable because you have set up a centralized solution. Centralized observability provides various benefits over a simple observability solution. Like it provides you enhanced visibility. Centralized observability provides us enhanced visibility as we'll be getting the data from more than one data source. So it will be easy for us to manage those data and look into the data, query the data, and see how our system is behaving or performing. Second benefit is simplified troubleshooting. As this solution provides us a unified interface, so it will be easy for us to investigate the issue, correlate the events, and identify the root cause of the problem. As it is providing us the simplified troubleshooting, so it will be faster for us to troubleshoot the system, as the both things goes hand in hand. So if we have a centralized solution, it will be easy for us to identify the problem and then get the solution for it. This solution adds a significant value to the customer side, like enhance the visibility. So as we are getting a centralized data, it will be easy for us to know the behavior of our infrastructure. Second is improve the troubleshooting part. So as troubleshooting is improving, so we'll be having less downtime, which will be very helpful for the end user and customer as well. Third is cost cutting, as we'll be getting all the data of our resource utilization of our application and our workload. So it will be easy for us to resizing the infrastructure. So these are the solution and the tools which I've explored and implemented in my experimental Saturday, and they help me gaining skills in the Kubernetes part, which is now helping me in my projects as well. As a DevOps engineer, you should keep yourself updated regarding the new tools and technologies. So I would like to thank XenonStack for giving me the opportunity to explore these new tools and help me in enhancing my skills, which is helping me now in my projects as well. Thank you.